Alright, there we go. Hey boys, pull your stuff out. What are you doing? Every lesson. Okay, so today we're going to go through 11C and 11D. The only thing I need to teach you that you haven't already sort of learnt is how to calculate the standard deviation manually. So I've got two formulas up here. Firstly, the variance, which is this formula here, and I'll explain it as we're doing it. And the standard deviation is just the square root of whatever the variance is. So standard deviation and variance, they are both measures of spread. And we're going to discuss them more tomorrow, because we get our lesson first thing tomorrow, lessons back to back. When we're talking about normal distribution, and you might remember normal distribution, you have a mean, and then you have standard deviations that dictate the spread of that data. So that's what standard deviation is a measure of how far apart data pieces are. So this is the data set we've got, and are we told, is it a population or a sample? It just says data set. So to begin with, we're not going to distinguish. Today's probably a good time to have that conversation actually about population and a sample. Okay? So this is going to be something we're coming back to. So population is the whole group, sample is a small portion of it. So let's say we wanted to know the average height of year 11s. We could perform a sample of you guys, and that would be an indication of the average height of the population, but it's not going to be exactly accurate. If we wanted the exact result, we would need to measure every person to work out the average. Okay? So we have a sample is a subset or a small group of the larger population. Now when we're talking about population, we use mean, we use mu for the mean. When we're talking about a sample, we use x bar. Okay, that's why you've seen x bar. That means the average of a population, that means the average from a sample. Alright, we also have standard deviation of a population, and we use lowercase s for the standard deviation of a sample. Alright, so just when you're seeing different notation there, that's what they mean. I'll point out this in a moment when we pull it up on our calculator. Anyway, let's get into calculating the variance and so forth, the standard deviation. In order to calculate it, we need the mean. So the very first thing we're going to do is find the mean here. So the mean is going to be 1 plus 1 plus 2 plus 3 divided by 4. So it's at 2 plus 2 is 6. It's 9 on 4, which is 2.25. Okay, that is the mean. Alright, we can do that on our calculator. And then we're ready to calculate the standard deviation. So let me explain what these symbols mean. Some of you have seen it before. This is the sum of all the data sets from the first data set to the nth data set. Okay? So we have 4 pieces of data. And so we're going to add up from the first data set to the 4th piece. And it's each data piece take the mean squared. Okay, so let's show you what that looks like in the formula. So the variance is going to be the sum of each data piece. Okay, so the first data piece is 1. So it's going to be 1 take the mean squared. Okay. The second data piece is also 1, isn't it? It's 1 take the mean squared. Okay, the third data piece is 2, so we're going to have plus that data piece, take the mean squared. And then the last data piece is 3, so it's going to be plus 3 take the mean squared. Okay, so I'm going to add all of them up and then divide that all by how many data pieces are there? 4. Okay, so I'm going to do that in my calculator now. It's going to take a little bit. Squared divided by 4, I've got 0.9375, or to 3 significant figures, 0.938. And remember, the standard deviation is the square root of the variance. So the standard deviation is going to be the square root of 0.9375, which is root 15 on 4, 0.968. Okay, so we're performing these calculations here. What's the significance of these numbers? This is the variance, this is the standard deviation. They are both measures of spread. How do we do it? Each result, take the mean squared, add them all up for each result. Okay, from the first data piece to the last data piece, divided by how many data pieces there are. And that's going to be the variance for a population. So that's how we can generate it manually, right? Yesterday on Monday, we learned how to do it in our calculator. So let's quickly pull our calculators out and we'll go through those calculator skills again. We're going to put data just in one list. So we're going into statistics. I won't bring it up because I think we're pretty familiar with it at this stage. So just in list 1, I'm going to put the data set 1, 1, 2, 3. So I'll delete whatever's there first. 1, 1, 2, 3. Now, when we have data only in one list, what should our settings say? Our settings should be list 1 and then the number 1. Alright, so check your settings, make sure it says list 1 and then the first variance frequency is the number 1. So we made a horrible blunder here, well I did. Okay, 2 plus 2 plus 3 is 7, guys, not 9. So anyway, that's just totally messed everything up. Okay.
It's a bit embarrassing.
It's awfully embarrassing.
For a maths
But
major.
it's all embarrassing for you guys because you failed the test to point it out when it happened.
No,
Okay, no, you're right. It is embarrassing for me. All right. So anyway, what I was trying to show you there is that when you calculate the first variable again, it's going to bring up for you. If you go down all your variables there, you've got the mean, you've got sigma of x and s of x. Okay. So you've got the standard deviation of the population and the standard deviation of the sample. Remember, I told you the difference between them over there. Okay. One's for a population, one's for a sample. It's just including both potential data pieces. And so that should be the same if we had got this number correct over here. Disaster. Alright, so that's how to calculate standard deviation manually. You'll be asked that a couple of times today. Alright, 7C, 7D, let's do it.